Hi, I'm Debbie Nelson with the Define Success Network. Today's interview is with Jason Laing with ProMake. And we met online in 2019, I think it was, Jay, in the summertime.
Yeah.
And I'm here in America, and I put a post out really late at night. I was working, and just to see who might respond, since after all, the world is online. And got an immediate response from Jay, and we've been talking ever since. I saw his fascinating TED Talk. Look it up if you haven't seen it yet. And so now Jay is following, well, I've been following his career ever since, and he's got a terrific company named ProMake. So Jay, tell us what it is that has meant so much to you in coming along and getting involved with graphene.
Graphene itself was never what I've expected to ever be. Originally coming from South Africa, it was one of those things that you always heard about, like in science magazines, and
Right.
always saw on science TV, and it was one of those big, like, ooh wow kind of type of scenarios. Never did I expect in my wildest dreams that I'd actually be physically involved with the material itself. And the graphene itself has really been revolutionary into not only my own journey, but into the company itself and where it's now gone. And COVID obviously affected a lot of people, but for us, it really excited the situation in a very positive way as to what the potential with this material can do. So it's been a fantastic journey, really.
Wow, that's great. Well, now you started off in South Africa. You ended up going up to um, into the UK. So, and you're still there. You're based in the UK, right?
Yeah, as you mentioned with my TED talk, it's got a part of my journey. What brought me here is after a serious accident and utilizing 3D printing to put me back together again. It led us to now working with graphene in the medtech sector. I was then granted the global talent visa for the UK. Came across to do further research, got involved with the universities in the graphene itself, and accelerated from there.
Talking about working in healthcare with graphene, and what exactly are you doing? Is it still with 3D printing?
Yeah, it is. Graphene has fantastic possibilities to enter into so many sectors within the healthcare sector. From a materials point of view, it opens a door for, like, let's take into the likes of like prosthetics or adaptive devices.
Oh, right.
Now, being able to put graphene into 3D printing materials, into polymers, opens a whole new door where we're able to go from, we obviously heard about 3D printing as a 3D construct, but being able to now take it and enter into what we call 4D printing, where, it's a bit of mentally it kind of messes your head a bit, like, what do you mean by 4D? Because 4D is obviously associated to time. And what we essentially say about 4D is we add a whole new realm of analytics or processes with the material itself, meaning that, let's say, if you 3D print you print it in, say, a PLA or an ABS plastic, it's all good and well. You can print a cup and you can put it on the counter and you can put some fluids into it or whatever you want into it. But that's all it is. It's a scaffold. It's still a plastic cup, really. But with the graphene side of things, we can now digitize the materials, meaning we can actually now start working out what is the pH level of the fluid inside of the cup itself by the analytics that we're able to pull from the digitized materials. So we can start using it as a way for preventative maintenance and starting to detect any anomalies in the material or the functional material or functional of the part, without having to have all these internal electronics to be able to do it. We can actually just run a current through it, or we can run a like thermoconductivity sensor on it. It opens a lot of doors. So from a medical perspective, going back to prosthetics, we can now start planning ways to add what we call explosive power. So take, for instance, like an athlete. If he's running down a track, you've got a good leg and he's got a prosthetic on the other. A lot of times is, how do you match the power output of the good leg with the prosthesis? So sometimes you would have seen when the guys are running with a prosthesis, it kind of looks like they're dragging the prosthesis behind them, or they're trying to overstriding, or they're trying to get themselves a balance. Being able to refine the material, we can actually start working out the power release and the potential power charge within the material, so they get a symmetry in the stride when the athlete's running. So if you take that as a baseline, right, you then be able to analyze that. You'll be able to put sensory devices on it to be able to pull all sorts of further algorithms. So if you had to take that as a way of kind of planning or programming the prosthesis, opens a lot of doors for other industries. Because you think about what is a prosthesis, it's a real mechanical engineered piece which can be used in the same methodology into engineering, into automotive, into aerospace, because the principles kind of remain the same as far as flexural strain, impact. There's a lot that can come from it. So graphene is something that really opens the doors, because you wouldn't be able to do this with any other materials really. And you can't just do it from a basic plastic. It's just how it goes.
Yeah. Wow, that it sounds like it, for the athlete, it's going to make things more normalized for them to be able to move.
Not necessarily just an athlete. It opens the doors for general people. You know, people that have just had some form of traumatic injury, and now having to try and get some form of way back to normal life. It kind of gives them that confidence that they're performing like they were before. So mentally, it helps a full string of things for patients.
That's fantastic. Now, how far along are you on things like this? When could we expect to see something that people can start using?
So we already got the materials into filaments and different other forms of UV polymers. So being able to do that, we're already starting to make parts and start to make test parts. We've got some projects in the go right now to test the flexural strain. You know, we already worked out, take for instance a plastic that most use on these normal home hobby 3D printers called PLA, right, which is like a polylactic acid plastic. Really, it's a general, like, how can I put it, level entry kind of polymer that we work with. Now, by adding the graphene to it, we compared that particular material against carbon fiber filaments that run on other high-end machines. And in some cases, the graphene actually either matched or outperformed in PLA versus carbon fiber. So it's almost like a molecular form of carbon fiber. So we know that we're already getting good results, we already get good feedback, which makes it cost effective, makes it commercial viability, and it makes it ease of use to be able to help engineers or technicians within the medtech sector start working with us without having to implement the massive cost that comes with it if you had to go through a normal high professional line of machines. So we're already there. Yeah,
that's fantastic. Now, are you working with any particular companies that are making prosthetics yet, or is